Good morning, everyone. Myself Gautam Sharma. I welcome you all in a Sapiens Education. Today, I am going to discuss about the compound microscope and telescope. This part 10th. This is the 10th part of the video, and if you want further more details topic, just you can visit our playlist. So let's discuss about the compound microscope and telescope. Before understanding the compound microscopes, we need to understand that there is a what is simple microscope. Let us understood that this is a convex lens. So convex lens will also act as a microscope because it basically magnifies the image of the object. So when you place an object between focal length, focal length as well as optical center, so what we will observe that it will produce a magnified real image and erect image. Got it? So let us consider this is an object A as well as B. It is an object, and as you know that the ray of parallel beam of light when will fall, so it will bend toward bend with the focus, and when another ray of light which will pass up through optical center, so they will diverge. So definitely from here when we trace back, so we will get the image, and this image is considered as A dash as well as B dash. Got it? Now we can understand that this distance between optical center and the focal length is your f is your focal length. And when we talk about the object distance, so let us consider this is an object, so this is an object, so u can be considered as an object distance. And when we talk about the image, so if you want a clarified image, so let us consider if you want clear cut image, so image should be formed from the lens at a 25 minimum 25 centimeter distance, otherwise it will be not clear. So let us consider this is your image distance, that is b, and this b can also be considered as a d only, or d. Why d? Because d is equal to 25 centimeter, and it is least, d is your least distinct of vision, least distance for distinct vision, right? Least distance for the distinct vision. Now you know that. Now everything is okay. I hope it is okay now. Now we know that mirror formula, lens formula is that lens formula that 1 by f is equal to 1 by b minus 1 by u. Now here focal length is f, okay, it's no problem. So image distance is f. So from here what we can do is that can we multiply it by b? So if we multiply it by b, so this will be b by f is equal to 1 minus b by u. Okay, b by u. Now we know that b by u is the magnification. So b by u is the magnification. So from here we can write here b by u is equal to 1 minus b by f. Now if we put this value distance, so since it is your negative distance, we will consider as a negative. So can we put here 1 minus d by f. So from here b by u is our magnification. So from here what we can consider that magnification is equal to 1 plus d by f. So this is your magnification. Why this I am writing magnification is equal to 1 plus d by f? Let us consider, we will here compare with the angle. So all instrument is in all instrument we will consider angular magnification only, angular magnification. Now magnification is equal to image angle formed by the image at the optical center. So let us consider the image. So this is a dash b dash, this is forming an image at image is forming an angle of, let us consider this is your beta. So beta, it is the ratio of the angle formed by the image divided by angle formed by the object. So when we observe this here object, so object is also forming an angle, but we need to understand that this object must be placed at the same line as the image is there. Why? Because we cannot compare different at a different place. Whenever you want to compare the angle, so your object should be placed at the same line. Object or image both should be placed at a same point. So let us consider, we can shift this object here also. If it is shift as a object here also, so this will this it become a and b. Now we can so earlier it was b dash, now we can compare it. So when, how you will compare it? The image, this sorry, this object is forming an angle, and this angle is considered as an alpha. So from here we can say that the magnification is equal to beta by alpha. Magnification is equal to beta by alpha. Our assumption is that assumption is that angle are very small. Angles are very small. If angle are very small, that is theta is very small, so we can write here m is equal to 10 beta divided by 10 alpha. Okay, so we can write 10 beta divided by 10 alpha. When we consider 10 beta, so we have to take as a large angle, so large triangle. So large triangle can be written as a dash b divided by ob dash 10. Now a dash b divided by ob dash. Now we can write 10 alpha. 10 alpha can be considered as perpendicular by base, that is a b dash, so that is also b dash, a b dash divided by b dash o b dash. So o b dash can get cancel out. O b dash get cancel out. So from here what we are getting? We are getting as a dash b dash by ab. Now a dash b dash by ab. Now if we talk about this triangle a dash, this triangle, that is if we talk about this triangle a dash b dash and o, and a b and o, what we can infer from here, that a dash b dash divided by ab can be written as ob dash divided by ob. So from here we can write here a dash b dash by ab is equal to ob dash divided by ob. Now ob dash is what? ob dash is what? ob dash is image distance, that is minus v, or ob is what? Object distance, so that is minus u. So finally m is equal to v minus u. Finally m is equal to v by u. So that's why I have placed this magnification in place of this b by u. We can write here magnification. So finally what we have derived is that m, so m is equal to 1 plus d by f. So this is our derivation. So whenever we will fill this type of situation, so we will use this magnification scenario. So I hope you have understood this. Now let us go for discussion of a compound microscope. Okay, so I hope you all have written all the topics. So thank you, and I will now discuss about a compound microscope. So what is compound microscope? Basically it's a microscope only. The thing is that we have to magnify the object size into huge. So how you will do? So first of all, try to understand that what we need to understand that, let us consider this is A and B as an object. Got it? And this is a objective lens, means it is nearby object, so that is objective lens. Got it? Now when we put any object near the objective lens, so what happens? Parallel beam of light will form, and this will create a image like this, A dash B dash, which is real and inverted, right? So this is the image formed by the objective lens. Got it? Now now we will place a eyepiece lens in such a way that that the object should be placed between the focal length Fe means focal length of the eyepiece. So this is focal length of the eyepiece. So I hope you have understood. And we want now at last step, we want clear cut image. That is, the image should be formed at the D, that is least distinct of vision. So in this way we can understand. Now since we have already done this equation, that when the scenario will come like this, when an object is placed between focal length and objective, so its image is virtual and erect, and we can derive m is equal to 1 plus d by f. So from here what we can write from, let us consider this is the lens E, and let us consider this is lens objective. Now for this lens what we can write, we can write that mass of the magnification of the eyepiece can be written as 1 plus d by fe. Why we have writing this? Because we have already considered that the image is formed at a this distinct of vision, because we want clear cut image, clear precise image. Now when we talk about the objective, so what will be the magnification of the objective? So magnification of the objective is equal to v by u naught. Okay, since object is in front of it, so we are putting a symbol minus. Okay, we are putting a symbol. See here, whatever we are deriving the relation, we are putting all the symbols and all. Now 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 we need to understand that our target is to find the magnification, right? Our target is to find the magnification, right? So before that magnification, we need to find that what angle is formed by an object, and what image is formed, what angle is formed by the image at the optical center. So let us consider A dash and B dash are the image, and it is forming an beta image, right? And the object BA is forming an angle alpha. It is forming an angle, object is forming an angle of how much? Alpha with this optical center. See here. So can see here, when we talk about this object, so how much angle is formed by this object? This is an angle alpha, so we can find this as an angle alpha. Okay, so tan beta can be considered as A double dash B double dash by AE, and tan alpha can be considered as AB divided by AB divided by AE, right? Now we have to find angular magnification, because we have already told that whatever comparison is of the magnification will be done in terms of angular magnification only. So this is the angular magnification. So angular magnification, right? So that is equal to m is equal to beta by alpha. So that is equal to tan beta divided by tan alpha, right? So from here what we can write here, a double dash b double dash divided by b double dash o, not b double dash, it will be how much, it will be, now this is your a dash b dash by ae divided by ab divided by a. Now a got cancelled, so finally we are getting magnification is equal to a double dash b double dash divided by ab. Now this can also be written as a double dash b double dash divided by a dash b dash is equal to, sorry, into a dash b dash divided by ab, because this both will get cancelled out. Now finally what we can do here, a double dash b double dash is what, the object's height, sorry, image height, it is image height, and a dash b dash is the object height. So for eyepiece, let us consider this is the eyepiece lens, this is your, see, this is eyepiece lens. So for eyepiece this will be object. Again I'm telling you, see here what actually happens in the compound microscope. If you are talking about the object, so this is an object a b. Now with objective lens it has magnified to a dash b dash, so little bit it has made a larger. Now this will act as an object, so a dash b dash will act as an object, and for the lens le, and a double dash and b double dash will act as an image. So when we talk about the image distance by object distance, so that is magnification, but magnification of the eyepiece, so we can write here magnification of the eyepiece into, now a dash b dash. Now since here when we talk about the objective lens, that is o, so what happened, a b is your object height and a dash b dash is the image height. So image height by object height can be written as magnification, but what about the magnification, magnification of the objective, magnification of the objective. Now just we need to put the values, just we need to fit the values. What type of values, see here, we have already got the magnification of eyepiece, we have already got the magnification of the objective lens. So magnification of the objective lens is how much, it is your v naught by u naught, v naught by u naught, that is equal to, see here this is the image distance, this is object distance, okay, but we are putting some symbol. Why? Because after that, after derivation we will not again put symbol while solving a numerical. Now what what about the eyepiece, eyepiece magnification. So eyepiece magnification is equal to 1 plus d by fe, okay. So this is magnification, right, this is magnification. So finally magnification, we have magnification is equal to minus v naught by u naught 1 plus d by fe. So this is the derivation for the, this is the derivation for the compound microscope. So I hope you have understood this formula, okay. So now we will discuss about the astronomical telescope. Let us go for the astronomical telescope. So what happens is, this is the diagram for the astronomical telescopes, okay, where we have two lenses, that is one lens is considered as an objective lens and another is your eye lens. So light from infinity will converge to form the image at a focus of the objective lens. Why? Because we know that the image light from the object which is at a very large distance will form at a image at a focus only. Got it? Because telescope, astronomical telescope is basically use of the astronomical telescope is to find see the image, see the object which is at a very far away distance. So let us consider the object's rays are coming at an angle alpha. So what is the object's angle? So definitely alpha with the optical center, right? Now where they will form the image? So definitely they will form the image at ob- focus of the objective lens. Now I want this image to be seen by our eyes at a very large and clear image, as well as at an infinity, so that we can not feel stressed. So if you want any image to be formed of an object at an infinity, so you have to put the image object at a focus. So when you will put any object at a focus, so its image will be formed at infinity. So this is the case, this is the condition we will use here, right? So let us see here this object. See here, this will behave as an object for this eye lens, which is nearby the eyepiece. Now, what is the distance between this lens as well as this one? So definitely when we will adjust this lens, eye lens, in such a way that the object or the this image will act as an object, and which will be placed at the focal point of the eye lens. So let us consider this the focal point of the eye lens, right? So this is the focal point of the eye lens, right? This is the focal point, and at this focal point when you put an object, so definitely its image will be at infinity. So its image will be at infinity, right? So we will now compare it. So comparing means what? When we are comparing about the magnification, so this will be what? So this will be equal to beta by alpha. Beta by alpha. Why? Beta is the image forming an angle. So this is the image is forming at infinity, and it is making an angle beta, see here, and the object is forming an angle alpha. So 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 we need to find beta as well as alpha. So how you will write here? We can write here 10 beta divided by 10 alpha, right? 10 alpha. Now what is 10 beta as well as 10 alpha? When we talk about the 10 beta, so 10 beta is equal to perpendicular by base, so that is equal to m is equal to perpendicular means what? B dash a dash, so or a dash b dash divided by c2b. See here, c2b, because it is triangle, so this will be c2b divided by what is 10 alpha? 10 alpha is again equal to a dash b dash divided by, see, this is an angle alpha, right? Because it is vertically opposite angle, so we can consider this as alpha. Now this can be written as c1b. So finally a dash b dash got cancelled out. So what we are getting? We are getting as c1b divided by c2b. Got it? Now what is c and b? C1b is your focal length of the objective, so this is equal to fo. Since it is in this direction, so we can take it positive. What about fe? So fe is in this direction, so we are considering this direction, so this length is fe. C2b is basically fe, so we can put here fe with the negative symbol. So finally we have got as magnification is equal to minus fo by fa. And when we talk about the length of the telescope, so length of the telescope will be definitely this length, right? So this length can be considered as length of focal length plus FE, right? So this is the length of the telescope. So I hope you have understood. So this is the normal adjustment, right? It is a normal adjustment. It is your normal adjustment. Normal adjustment condition. Adjustment condition. So there are one more condition. So but as per the syllabus, this is the sufficient. One more thing I have forgot to derive, that is your length of the compound microscope. So when we talk about the length of the compound microscope, L is equal to length of the compound microscope. This will be equal to this distance. So this distance is equal to, how you will write? How you will write this? Try to think by yourself. So then see, very easy. It's VO plus BE. See, this distance is VO plus UE, right? So we can write length of the telescope compound microscope is at image distance plus object distance, UE. UE. Okay. So by this way you need to solve this. Okay. So one more important thing I have not yet mentioned, that whenever while using a formula, while using instrument formula instrument formula don't use signs, as we have already considered one time. Okay, so I hope you have understood this. Thank you for watching my video.